So we're finishing up problem number 3 here. We found that the new um, surface area a squared value is 1 over 16. So basically what we do is it told us that the original surface area is 736. We take that 736, all right, 736, and we multiply it by 1 over 16, which is the same thing as dividing by 16. And that gives us 46 inches squared for the surface area of the smaller figure. Okay. So for question number 4 is a little bit more involved, I guess, but they always get challenging as we go along. So basically for this one, we have cone A is similar to cone B. Okay. Cone A has a surface area of 1,422 and cone B has a surface area of 158. How many times larger is cone A than cone B? So what we're looking for is how many times larger. So if we're going something that's larger, all right. So I think in problem number 1, where it asks how many times larger will the surface area be, I think about, number 2 where it says multiplied by 5. So for this one, basically we're multiplying, and I'm going to erase problem number 3 so I got a little bit more room to work with here. We have these two cones, okay? So we have cone A, and then we have cone B. So this is cone A, and this is cone B. We have their surface areas, and we're saying how many times larger is cone A than cone B? So basically we're trying to go figure out what A is. So if we're figuring out what A is, A equals, and we're saying B times some value will give us A. That's what when it says how many times larger is cone A than cone B, it's saying what value times the surface area of cone B will give us the surface area of cone A. Well, that value we found out, and we've been doing this the whole time. If you look up at problem number 2, it was the 25 was our A squared, so we took the first value and then we multiplied it by our A squared value and got that second surface area. So for this one, what we're saying is we're multiplying by that A squared value, okay? So we're taking, the surface area of cone B, multiplying by that A squared value, and that's going to give us the surface area of cone A. That's what we normally would do. That's as far as we kind of got before. But this time is a little bit different because we're going to have to find that A squared value first. We know the two other surface areas, so we're going to find that A squared value, that relationship that they have. So to do that, when we set up our equation, we're using this formula here. We're saying 1,422 equals 158 times our A squared value. Well, to solve for A squared, we're going to divide by 158 on this side. That's going to cancel, and we divide by 158 on the other side, giving us A squared equal to 9. So that is our A squared value. That's the relationship between the surface areas, okay? What it's asking, though, is how many times larger is cone A than cone B? It doesn't ask how many times larger is the surface area, just how much times larger. So basically, I think of dimensions. If this slant height is 3, what's going to be this slant height? That's what they're looking for. Anytime they're looking for how much larger, stuff like that, it's talking about the dimensions or just the scale factor. So what we want to do now is go from A squared, and we want to find our A value. So all we have to do for this to go from A squared to A is take the square root of that, take the square root of that. So when we do that, when we take the square root of 9, that gives us our A value of 3. So how many times larger? Well, 3 times larger. 3 times larger, meaning if B had a dimension of a slant height of 3, all we'd have to do is we say